Hi friends, today we are going to solve LeetCode 62 unique paths problem. There is a robot on M by N grid. The robot is initially located at top left corner, that is grid 0, 0. The robot try to move bottom right corner to this finish cell. So the robot can move either down or right at any point of time. So this is the down direction and this is the right direction. So given two integers m and n, this represents grid size. We need to written number of possible paths that robot can take to reach the bottom right corner. So we need to written number of ways this robot can reach finish. Let's understand the problem from example 2. We got 3 by 2 matrix, that means 3 rows and 2 columns. For this output is 3. So those are this pink line represent first way to reach the destination. So this is right, down, down. Second possibility represents this green line. So down, down, right. Third possibility or third path is down, right, down. So this black line represents. Let's see different approaches to solve this particular problem. Approach 1 is using recursion. We got the 3 by 7 grid, that means 3 rows and 7 columns. Our destination cell is 2, 6. This is the destination cell. So robot can reach the destination cell from 25, cell 25 or 16. So the number of ways to reach cell 26 is the sum of the number of ways to reach cell 16, up cell 16, and the number of ways to reach left cell 25. Similar to destination, we need to calculate number of ways to reach cell up cell 16. So to calculate up cell 16, we dependent on 06 cell and 15 cell. To calculate for 15 cell, we dependent on 05 and 014. This is the code. It takes two inputs. First one is the row index and second one is the column index. If you see here, first of all, we are calculating number of ways to reach for left cell and we are calculating number of ways to reach right cell. That is r minus 1 comma c, and we are summing it up and returning as the result. This is the base conditions for recursion. So if it is the starting position, we are returning 1. If it is representing out of grid, we are simply returning 0. This is the recursion call stack. So finally we need to calculate for destination cell, right, at 26. So we started at 26. Okay, so to calculate number of ways to reach 26, so we are calculating up cell 16 and we are calculating left cell 25. In similar way, to calculate for 16, we are calculating for 06 and 15. So I didn't draw complete call stack. I draw only 2 levels. Okay, so from these 2 levels, if you observe 15, right? So we are calculating for cell 15, we are calculating multiple times. Similar way for cell 205 also we are calculating multiple times. So this recursion has repeating subproblems. Yes, call stack has repeating subproblems. Dynamic programming or DP suits more over recursion for this particular problem. So approach 1 is not the optimal way to solve this particular problem. Dynamic programming or DP is optimization over simple recursion if recursion contains repeated subproblems. If you see our recursion call stack, we can clearly observe repeated subproblems. For cell 15, we are calculating multiple times. Similarly, for cell 05 also we are computing multiple times. So if you take full recursion call stack, we can see many repeated subproblems. For these kind of problems, DP is more suitable.
Second approach is based on dynamic programming. In dynamic programming, we have two techniques. One is memoization and another is tabulation. Okay, so if we take memoization, in memoization, we use recursion only, but we store the recorded result of the calculated value, and for further calls, we simply return the stored result. So we won't calculate. This is the pseudocode for memoization. We declare the DP array. We initialize the DP array with -1. That -1 means it is not calculated for that particular cell. Initially for start position we assign 1. So this R represent row index, C represent column index. Okay, if we see, if dp of rc equal to -1 means this is not calculated. So at that time we are generating the recursion tree and we are calculating the result. Once we calculated the result, if you observe left side, we are storing the calculated result and we are returning the result. For second time onwards we won't calculate because dp of rc is not -1. So time space complexity wise, okay, so for dp array it takes order of m into n, where m represents the number of rows, n represents the number of columns. For, apart from that, actually for recursion call stack also it takes order of mn. Okay, so time complexity also it takes order of mn. Actually for each cell we are using 2 times, so effectively it is order of mn. In case of tabulation we won't use recursion. This is the pseudocode for tabulation. So we declared dp array and we initialized some values for first row and first column. Okay, so in dry run we see in detail. Okay, so if you see, we simply run for loop, we don't have any recursion or call stack kind of. Okay, so space complexity wise it takes order of mn as per this dp array. For this, as we are not using the recursion, there is no overhead of recursion call stack. So time complexity also order of order of mn. So tabulation is more optimal way for this particular problem. Now let us try run the 3 by 7 grid. So for 3 by 7 grid, result is 28. This 28 I copied from the LeetCode problem description. If our starting position is 0, 0 cell, so I pre-filled 0, 0 cell with value 1. If you take this cell, okay, now we will calculate first row first. So if you take first row, so this 0, 1 cell, how many ways we can reach? From left we can reach one way, and from top there is no grid, right? So no cell, right? So 0 ways. So overall it is one way to reach cell 0, 1. So let's calculate 0, 2 cell. So from left one way we can reach, from top 0 ways. So overall it's one only. So if you take for entire first row, same happens. So only one way we can reach. Now we will calculate for first column, that is 0th column. So how many ways we can reach to this particular cell? From left 0 ways and from top 1 way. Overall it is 1. So for this one also, from left 0 ways, from top 1 way. So overall it is 1. Okay, so now calculate for this particular cell, 1, 1 cell. From left how many ways we can reach? 1. From top how many ways we can reach? 1. So overall it is 2. If you take this from left 2 ways, okay, from top how many ways? 1 way. So overall it is 3. If you take this cell, how many ways from left we can reach? We can reach 3 ways. From this, from top how many ways? 1. So it is 4. So I'm quickly filling this equal to 5. 5 plus 1 equal to 6. Okay, so for this cell, from left 6 ways and from top 1 way. So overall it is 7 ways. So let us fill with the same formula. Let us fill this one. Okay, so if you take this from left, how many ways we will fill? 1 way. From top 2 ways. So overall it is 3 ways. So if you take this from left 3 ways, from top also 3 ways. Overall it is 6 ways. For this particular cell, from left 6 ways, from top 4 ways. Overall it is 10 ways. If you take this from left 10 ways, we can reach, from top 5 ways we can reach. So overall it is 15 ways. Okay, so if you take this cell, from left it is 15 ways, from top it is 6 ways. Overall it is 21 ways. If you take this from left 21 ways and from top 7 ways. So overall it is 28 ways. So this 28 matched with the result. So this is the code. So time complexity for this particular problem is order of mn, where m is the number of rows, n is the number of columns. Space complexity also order of mn. For the interest of time, I already typed the code. Let me walk you through the code. Here we declared the dp array. Okay, so here I am initializing the first row and first column with the values 1. If you understand the dry run correctly, first row and first column always 1. So same I am initializing here. So for remaining cells we are calculating and assigning value here. We are starting from the row 1 to the last row. We are column wise, we are starting from first column to last column. Okay, so to fill the ij column, we are summing up values of already calculated left cell and already calculated top cell. Okay, so finally we are returning m minus 1, n minus 1. So these are the indexes for last cell. Let me run this code. Yeah, sample test cases got passed. Okay, so let me submit this. Yeah, it's submitted and it beats the 100% submissions. Yeah, if you like the content, like the video and subscribe. Thank you.